Cisco instructor Andrea here, and this video review will be covering Module 2 in the CNT140 class. Basically, it's going to go over basic device configuration and some commands that we'll be using throughout the whole class. And it starts to explain how we'll get into these devices in order to manage them and configure them. A little word about this particular module. It is fairly long, and this video goes, I think, over an hour. So just pre-plan your time and take breaks. There are spots throughout the video that I recommend where you take a break. If you need more, by all means, take more. Just want you to know ahead of time. Let's get started. If you remember, or if you watched the last video from Module 1, we went over a preview of some important topics to be looking out for when you cover Module 2. I'll just highlight these again. The main components of an OS, and OS stands for operating system. All computer devices, networking devices have an operating system. What is in-band versus out-of-band? Console connections, basic device CLI commands, basic device security commands, what is the running configuration and the startup configuration, what is a switch virtual interface, what is an IP address, NVRAM, interfaces, ports, and media. Remember, this is not an exhaustive list, okay? These are just some of the highlights that we want you to pay attention to. As you go through the module, either through this video or reading it or covering other available resources through the learning resources, if there's something that jumps out at you as important or something you want more understanding on, make sure you write it down and take notes. Okay, so just to recap, this is not an exhaustive video, and there will be some things that I don't cover in detail because we'll be doing them in class or they'll be part of our labs. Let's start with a question. All network equipment is dependent upon a what or an what? And I actually already said it. So this is kind of to see whether or not you caught that. This is a multiple choice question. The cost of your device, an operating system, software, or having Wi-Fi. Well, we know that all network equipment isn't dependent upon a price, right? Because prices range. We also know that it doesn't have to have Wi-Fi. As a matter of fact, most network devices are going to be plugging into electricity as well as having some sort of hardwired connection to the internet. Software changes, right? There's all different types of software. So hopefully you answered an operating system. So just like your computer needs an operating system, Linux, or it needs Windows, something, the Macs need the Mac OS, so does a router and a switch. It needs an iOS, okay, an operating system. Networking equipment is dependent upon the operating system, exactly the way a home computer is reliant upon its operating system. If you don't put an operating system on your home computer, there's not a lot of stuff you can do with it. The network operating system used on Cisco devices is called the Cisco IOS, the Cisco Information Internetwork Operating System. Okay. So what are the components of an operating system? And these components are the same regardless of whether or not we're talking about a computer, a router, or a switch. The blank interacts directly with computer hardware. Now we actually have a little bit of a diagram right here too. So if you take a look here, you can see that this is called the kernel. The kernel is part of the operating system. The kernel is interacting with the hardware components of your networking device or your computer. The blank interfaces with the application user. So this is what I'm interacting with as a user, or what you are interacting with as a user. Now that's called the shell. So as the user, we're interacting with the shell. Okay, the kernel's interacting with the hardware. So we have some control or effect over the hardware because we can access that through the shell as a user. Now the user interacts with the shell, and we interact with the shell either using a GUI, which is an interface, right? It is an interface that we can access that's web-based, or the command line, the CLI. The role of an operating system is so that we as the user can interact with our networking devices or our computers, okay? We can use a mouse to select and run programs through the GUI. We could enter text through the CLI and enter commands. And then also we can see output on the monitor. If we're using a GUI system, we'll see that on the web-based GUI image. If we're using the command line, we'll see that in the command line image. The Cisco iOS does the same thing. It enables a technician to use the keyboard so that we can run command line based programs. We can use the keyboard to enter text and text-based commands and view output on the monitor. It's exactly the same. All networking devices, when you buy one, it will come with a default iOS. Now, we as network administrators can also upgrade that iOS if we want. If we have an older device, we could buy a newer iOS. Just like if you have an older computer, if its hardware is capable of handling a newer operating system, you can put a newer operating system on your computer. It's the same with Cisco devices. As a network administrator, we need to be able to interact with our network devices, because what we're going to be doing is giving them commands and configuring them so that they know what to do with data, and they know where to send data, how to receive data. And in order to do that, we need to be able to interact with either a GUI or a command line interface. Now, typically, network administrators are known to interface more with the command line. GUIs can be a little temperamental, and there's a lot of pointing and clicking. I will say, though, a lot has changed, and companies are moving more and more to this web-based GUI. And as you work like in the Amazon cloud, that's almost all GUI-based as well. So this GUI is becoming more and more common and popular. It's a little bit easier for some people because basically you're pointing and clicking versus having to understand how to put commands into a command line. Okay, so here's an example of a GUI. Again, it's web-based, right? And you would enter commands into it. It allows the user to interact with the system using an environment of graphical icons, menus, windows. The GUI is more user-friendly and requires less knowledge. However, again, it can be a little bit more temperamental. When accessing network devices such as routers and switches through the command line, so we're not using a GUI, we're actually using the command line, we can use one of three access methods. If you've already read the module or you've done any work with the labs or packet tracers, maybe you already know what these are. So let me give you a few seconds to think about that. All right, the first one is a console cable. Now this is a physical port that is on the networking device. And so you would take a cable and you would plug that into the device and then plug it into your computer, your laptop, and that's giving you a physical connection into that device that allows you to manage it through the command line. Here's an example of a console cable. Notice it's got an RS-232 serial port at the end. There's also kind that have USB ports on the end. Another way is through Secure Shell, SSH. Now this will establish a secure remote connection. This is the preferred method because it will encrypt all of the text that's going across the line, so it gives the user more security. Okay. Here's an interface into SSH using something called PuTTY. PuTTY is a terminal emulation program. This is just what allows us to get into the device. It's the interface application that the user can enter the commands through and get into the command line. Lastly, we can do Telnet. Now, Telnet establishes an insecure remote connection into the device. It's insecure just because it sends the information in plain text. There's no encryption, so if somebody is looking, they'll be able to see passwords, usernames, etc. Terminal emulation programs are used to connect to a network device by either the console port, SSH, or Telnet. So when we're using the console port, SSH, and Telnet, we do need to have that terminal emulation program to get the access. Okay. There's several different terminal emulations: PuTTY, Teraterm, Secure CRT. There's even more than that. In our class, we will be using Teraterm, okay? Now, we also have PuTTY loaded onto most of our computers, so you can also use PuTTY. And I recommend playing with both of them. I tend to use Teraterm just because it's simpler to use. You don't have to enter as much information. But at the same time, PuTTY does give you a little bit more granular information that you can enter. Okay, again, we will be doing these in their labs, plus in packet tracers. As we go through the labs, I want you to pay really close attention, especially in the first several weeks as we're doing these new things, so that you can gain a better understanding of how they work and how they give you access into these devices. Here's just a picture of what the application will show up to us on our computers when we're using Teraterm. What is a common way to access the CLI environment of routers and switches? So what's the most common way? Our options here are dial-up, auxiliary port connection, switch virtual interface, or a console connection. Well, if you answered console connection, you would be right, and that's kind of what we've been talking about, is using the console connection. Okay. The next question I have for you is, when using the console port connection to manage a device, is this an in-band or an out-of-band connection? Understanding the difference between in-band and out-of-band is going to become really important as we're doing our labs. So the console port is a management port that provides out-of-band access, okay? And I'm going to show you a little example here. In this scenario, as the network administrator, let's say that I have built this small network where I'm connecting two PCs through some switches, okay? Just a small network. So if we build this small network, the next thing I need to do as the network administrator is I need to get into this switch and I need to get into this switch in order to give it some commands and tell it how it's supposed to handle the data traffic that's going to be moving across their links, across their media, okay? So to do that, I need to get into them and access the CLI. Now keep in mind, this is a network, so these devices are related to each other, okay? They're part of the same network. What I need to do is connect a console PC. So this is a separate third PC. Since this initial setup of these devices, we will use the console cable. Again, these devices have never been set up. So I've got to use a console PC and a console cable, which was that blue cable that we saw a few slides ago. This is an out-of-band connection because here, this console PC and the console cable aren't connected and part of this network. So it's something that's coming from the outside in order to give commands to the switches. Okay, that is out of band. Now, almost all the networking that we do in 140 is going to be out of band. Okay, and everything starts out of band because you have to configure the devices out of the box. Like when you take it out of the box, you've got to configure it. It's not part of a network. Everything's out of band until you give it some commands and some configurations that allows you as the network administrator or somebody else to manage it from within the network. Okay. So this is in the network, and this is coming from the outside. Now, once the administrator has configured something called a virtual interface on the switch, both of these switches, and give it an IP address, at that point, I no longer need the console PC. Once we've set the devices up with their initial configurations, now PCA or PCB from inside the network could manage these devices and give them additional commands or modify them. But we couldn't do that at first because they didn't have any commands. This is the in-band. What are two other methods to access the CLI environment of a Cisco device? Again, here's a multiple choice. A virtual terminal, a fast Ethernet port terminal, a serial interface terminal, an auxiliary port, or a walkie-talkie port. So I'm hoping you can eliminate at least one of those, right? The walkie-talkie port. We can get rid of that. Now, it's possible you are not familiar with these other terms, and so this would be a hard question to answer if you hadn't already done some reading and studying. So in this case, it's a virtual terminal. This is a way that we can get in using a virtual IP address that's been configured on the devices, or an auxiliary port. Okay, an auxiliary port. Now, with a virtual terminal, we would be able to use Telnet or SSH to get into the virtual terminal. Again, the advantage of SSH is that it's encrypted, so it's more secure. Now, an auxiliary port, that's just a plain old-fashioned phone line. It's a dial-up connection. Now, believe it or not, all networking devices still come with auxiliary ports, and they maintain that. And in most networking shops or centers, they will keep a telephone line going. And that's because if the electricity fails, or if they need to get in and they can't get in through their console port, they can still get in with the dial-up phone connection, dial-up phone port. Okay, here's an example right there of the console port, here where it's blue. And then right above that is the auxiliary port. Okay, the auxiliary port. Now we have a bunch of different routers and different switches in our lab, so you'll just have to look at each of them. And what I would recommend you do is that you take a look and you see if you can find the console port and the auxiliary port. Now, while we're talking about this, I do want to mention a little bit about our lab and our lab setup, because sometimes this can give people a little bit of confusion. In that picture that we saw back here, right, it would be me as the network administrator connecting maybe my laptop up to these devices. In our lab, we've actually pre-wired every device with a console cable already so that you can manage any of our networking devices from the desk in our classroom. Okay, So sometimes students are like, well, where's my console cable? What computer do I use to go plug in? You know, do I need to take a laptop back into the router room with one of those blue cables? You actually don't. And again, the reason you don't is because we've just pre-wired it to make it easy. So the console cable goes from your desk jacks down under the floor, over to the router room, up and down into the racks, and then every device is plugged in with a console cable. We will point this out in class and we'll talk about it, and we'll probably even go over in-band and out-of-band again because of how important it is to understand it. This module video review is fairly long, so if you want to just pause your video at this point and take a quick little break, I would recommend that. Stand up, stretch, make your eyes look off someplace else and get a drink, and then come back and then we'll go through the rest of this. Okay. Next, the command structure. So we just talked about how we get into the device. And the reason we need to get into the device is to give it commands. You could think of this a little bit like programming the device, right? It's not really programming because we're not using a program language, although we are using command structure that the router or the switch will recognize. So we're going to configure devices and enter the commands. Each operating system command has a very specific format. This is called a syntax. And if I'm not mistaken, that's actually a question on one of the brain teasers. The general syntax is the command, followed by any appropriate keyword or argument. So a keyword is a specific parameter defined in the operating system. If you enter in a keyword, the iOS will recognize that keyword and know what to do with it. And then an argument is something that is not predefined, so it might change. So the keyword is predefined, the iOS will recognize it. An argument is when there's an option and I have control over that. So here's an example. In this situation, we have the switch. So we're working on a switch. And we're telling it what we want the switch to do. That's the command. So we want the switch to ping something. What do we want it to ping? Well, we want it to ping an IP address that I enter into it. 192.168.10.5. Now, because this is a number that could be different, it would actually be an argument. So I could say ping 10.10.10.1. ping.192.100.10.5. So because that value can change, that would be considered an argument. Okay. Now at the bottom here is an example of using a keyword. Again, we're still on the switch. What do we want the switch to do this time? Well, we're going to command it to show. That means I want the switch to show me something. And then I enter IP protocols. Now, when I enter IP protocols, this would be a keyword. The switch recognizes that terminology, IP protocols, and then it goes into its database somewhere and it grabs that information and then it posts it out into the command line for me. Okay, there's our command. Here is our keyword, and then there is our argument. In the following command line, which word represents the command and which word represents the argument? Okay. Well, here's our command and north is our argument. Now, the reason north is an argument and not a keyword is because when you're setting a host name, what that means is you're giving your router, in this situation, a router, a name. And you can name it anything you want as long as it fits within the parameters that are allowed. So you could name it north, you could name it south, you could name it home office, branch office. So it's an argument because that is a value that can be changed. Okay. What mode of operation are we in? See, if you look right here and we see router and then config with this ampersand, the tag there, that's a particular type of mode. Again, if you've read the modules or you reviewed any other learning resources, you might know that that is global configuration mode. As we are giving commands to our devices, depending upon where we're at in the command, we will be in different modes. So different commands can be entered in different modes. Cisco iOS modes of operation, or the commands, okay? Cisco uses a hierarchical order from the most basic to the most specialized. I want you to name the 3 most common starting modes or the starting commands. These will be used every time you have to do a lab, every time you have to do a packet tracer. You'll see lots of brain teaser questions about them. So what are the modes? The first one is user executive mode. The next one is privileged executive mode. So it's the next one up on the hierarchy. So a privileged executive user has a little bit more privileges than just a regular user would have. And then the third most common mode is global configuration mode. So you enter in each of these modes to move into the next mode. There are other specific configuration modes that you can access once you're in global mode. You have to be in global mode to access the more specialized modes. Okay, here is an example of user exec mode and what you can do when you're in user exec mode. From user exec mode, you can use a ping command, you can use a show command, you can type the word enable. And the word enable is what moves you to the next mode. One way that you can tell when you are in user exec mode is when you see this little arrow on the end of your prompt, okay? The little arrow, the little greater than symbol. Then privileged exec mode, I have even more privileges. I can't do everything. I can do more though. Here I can do debugging commands, reloading, I can configure, I can save the running config, I can save the startup config. The way you can tell when you are in privileged exec mode is if you see the prompt and then just the tag, the ampersand or that number symbol, okay? Next, you have to go into global mode, okay? The way you go into global mode is with the command configure terminal. Configure terminal. Now, once you're in global mode, you can do a lot of stuff from global mode. Global mode is where you can access all the specialized commands, okay? Notice here with the way you can determine that you're in global mode is you see the word config in parentheses. So think of that like the globe, right? Like the globe. And if basically you can affect the whole device globally. So that's how you can remember it, is thinking, okay, I can affect the whole device when I'm in global mode. Here are a few examples of some of the other more specialized commands that you can access once you are in global configuration mode. Config if, which stands for interface. Config router, which means you're going to be affecting things that are specific to routing. Or config line, you're going to be affecting things that are related to specific lines in your command. Let's do a little matching and see what you picked up on from those last slides. If you see switch with the greater than symbol, which mode are you in? Privileged, interface mode, global configuration mode, or user exec mode. I hope you picked user exec mode. Next, switch with this number symbol or the hashtag symbol. What mode are you in? Did you pick privileged exec mode? We're going up one. The way that you go from user mode to privileged mode is with the command word enable, E-N-A-B-L-E, enable. All right, next, switch config with the hashtag. What mode are you in then? Think about this, right? I'm affecting the whole part of the device. In this case, it's a switch. Global configuration mode. How do you go from privileged mode to global mode? Well, you do that with the command configure space terminal, because I'm going to be configuring the terminal. Last one, this one's the most obvious, switch config if, IF. And IF stands for interface, and that's one of the specialty modes. These four we will do all the time, all the time. This just recaps going through these primary modes, user exec mode. We've got the greater than symbol, and you have very limited access. From here, I can go into privileged mode, where my access privileges go up a little bit, but they're still very limited. And then global configuration modes and those submodes or those specialty modes. Okay, here's an example of something that I can do in user exec mode. I can run a ping. I can do a show running config. I can use show commands in the privileged mode. With the global mode, I can start to set and go into the interfaces. Then I can set IP addresses on the interfaces. Again, each one is just taking me to a higher privilege level. Okay, global configuration mode is when you're changing the entire device. That's why it's called a global change or global configuration. All right, so how do we move through? We've already mentioned it. I'm just going to recap it because we're going to use them all the time. The key word, the command, enable is what allows you to move from user mode to privileged mode. Privileged mode is sometimes called the enable mode, okay? To move to global configuration mode from privileged mode, you use the command configure terminal. A really helpful command is the word exit. As you're moving through the command line and doing different commands, if you want to back up by one mode, you can type the word exit. Okay, you can type the word exit. If you want to back up again, you can type the word exit again. To enter line subconfiguration, you use the line command. We'll talk about this one more later. To move from any subconfiguration mode to the privileged mode, you can type the word end, or you can use Control-Z. So let's say you're all the way into the config IF mode, and you want to go back to privileged mode, kind of get back to the beginning. If you type the word end or Control-Z, that'll just take you back to privileged mode. So exit and end will become your friends. Exit backs you up one mode at a time, and takes you back to the privileged exec mode. When you are inside of the command line, there are other ways to get help that have been built into the Cisco iOS, and these are called context-sensitive help. Okay, context-sensitive help. Hotkeys, using shortcuts, and things like that. One of the context-sensitive help is using the question mark. There's a couple of different ways you can use the question mark. If you type in, you start to type a command and you're not really sure what the rest of it, the word is, like the actual command word, this is an example of clock. You can type CL with a question mark right after the L, and it will give you all of the different commands that start with CL. That might be enough to trigger, oh, I'm trying to set the clock on my device. That's one way. Another way to use the question mark is you putting a space, okay? So in this situation, I'm typing clock set because I want to set a time on my device. And if I do space question mark, it will give me what the next available part of that command is, and it will show me the structure. In this case, I want to set the clock, so I do clock set space question mark, and it tells me how I set it. So I have to set the hour first, colon, followed by the minutes, colon, followed by SS, the seconds. And I can keep doing that for the whole command. So notice I've now entered 1900 hours, 50 minutes, 0 seconds. And again, I still don't know what the next part of that command is. I can do space question mark. Oh, notice here, it wants to know what the day of the month is. Okay, what is the day of the month? It's the 29th. Okay, so I enter the 29th. Now I can do that all the way through till it gets me to the very end. That's context sensitive help. I want you to start using the question mark and the space question mark early on. Whenever you get stuck, try the question mark, right? Try the question mark first, then go into the lab and review the lab to see if you missed something. Then go into the book, see if you need to get something from there. But start getting practice using the ends, the exit, the question mark, okay? Here are just a couple of more hotkeys and shortcuts. I'm not going to go through all of them. You can read these. You can see them in the book. Not only that, I want you practicing them in the lab, okay? Well, let me go over a couple now that I think about it. The down arrow and the up arrow and the tab, super helpful. If you did a command and you need to do that same command again, but with a different argument, you can just hit the up arrow and it will take you back one, okay? The down arrow does the same thing. It's just allowing you to scroll up and down through what you've been doing, okay? Oh, one more super helpful one. Control-Shift-6. This will allow the user to interrupt wherever the processing is of the operating system. Control-Shift-6. My advice is that you make yourself a little Word document or make yourself a text file on a notepad and keep these handy. I'm going to give you just a few seconds to write these down or to pause your video. More about command syntax. As you are typing commands in, if you make a mistake, the command line and the iOS are going to give you some hints about what you did wrong, okay? And here is this error message: ambiguous command, incomplete command, invalid input. So for the ambiguous command, the letter C, well, there's probably 15 different commands that can start with the letter C. So it's ambiguous. It needs more information. This is the time when you might be able to use the question mark. If you're trying to set the clock and all you did was type clock set and enter, the iOS is going to say, I don't know what you're trying to do. This doesn't seem like a complete command. It will tell you incomplete command. And then lastly, if you do an invalid input, like something that it doesn't understand, it's not necessarily, it could be incomplete, but it could just also be like, that's whatever you put here in the command, this isn't the right place for it. And it gives you this little caret marker. I'm going to tell you something. The little caret marker isn't always exactly where the mistake is. The caret marker goes when the iOS detected it. So a lot of times it is where it belongs. Sometimes it isn't. This might be another good time to take a quick little break, walk away from your screen, rest your eyes, turn away, and then come back. We're still talking about the basic configurations, okay? One of the things that you will do on every lab and every packet tracer is assign your device a name, okay? Now, a lot of times in our labs, we're just assigning something R1, like router 1 or router 2, maybe even something like BR for branch router, okay? And then we also are going to put our initials at the end just so that we know who is on the devices. We do need to give everything a host name though. If we look at this, here we've got our switch config. So what mode are you in? Global configuration mode. My command is host name. The argument will be whatever name I choose to give to my router, okay? Or my switch in this case. Host names appear in the CLI prompts. They're part of the authentication process. That's why we have to give every device its own unique host name. We won't really be dealing very much with the authentication process until CNT140 when we dig much deeper into security. It's just something to keep in mind that that's why we need to do the host names. These should be used on all your topology diagrams. Remember, we talked about the physical topologies and the logical topologies in Module 1. They're case sensitive. So if you use a capital letter or a little letter, you have to carry that through. Okay. And there's a variety of different naming guidelines. Start with a letter. You can't start with a number or a character. Okay. You can't have any spaces in your host name. So let's say you had 3 different branch routers and you wanted to name your branch router BR. You could call one BR1, BR2, and BR3. They have to be unique and they can't have any spaces. So you can't say BR space 1. You could do BR hyphen 1 or BR underscore 1. Okay. You have to end with a letter or a number. You have to end with a letter or number. So you can't end with a hyphen. You can't end with an underscore. You can use those. It just can't be at the end. Use only letters, digits, and dashes. Okay. And your host name has to be less than 64 characters. In our class, we'll keep them fairly short. In the real world, it is not uncommon to see very long host names. And the reason is partly a security measure. And the other reason is because a lot of times network administrators like to use descriptive terminology when they're naming their devices so they can get an understanding of maybe where they're located, what networks they're handling, etc. For us, in our class, I want you to always use your initials. So here's an example of a command that I might use if I'm going into the router and giving it a name. I'm going to say command is host name, R1 standing for router 1, and then I put my initials on it, ALS. You will use your initials. Don't use my initials. That happens all the time, okay? And sometimes I have people who have the same initials as me. But the reason we do that is because then if there's something on a device that we need to tell you about or have you erase something on the device, we know who was on there. Here's an example. If I were working in a team with somebody, because sometimes you might end up doing a lab with another person. Then what I would do is I would give it a name, S1, that stands for switch 1, hyphen ALS, and then PK for the initials of whoever my lab partner is. Here's our command, and R1ALS. Is that an argument or is that a keyword? It is an argument because it's changeable. These next few slides are going to be about more commands, but commands that relate to security and securing your devices. Remember, a lot of us are going to be going into cybersecurity or we just need to understand general security practices. And this is where it all begins. So blank are the primary defense against unauthorized access to network devices. Now, this is the same for anything, our cell phone, our computers. What do we use to prevent people from getting on them that we don't want on them. Passwords, right? The Cisco iOS accepts several passwords for different access privilege. Now, we talked about user mode, privileged mode, global mode. Each of those come with a password that you can set. So if the person doesn't have that password, they can't get to the next mode, okay? The keyword enable moves you from user executive mode to what mode? Privileged mode, privileged exec mode. Well, there is a command that encrypts and limits access to the privileged exec mode. Do you know what that command is? It is enable secret. If you remember on a previous slide, we said that sometimes the privileged exec mode is also called the enable mode. Well, the reason is because you have to type the keyword enable to move to the privileged mode. Well, if you want to protect it, then what you would do is you would type enable secret and then whatever the password is. So like enable secret high five, enable secret I'm going to Hawaii, okay? This next password command limits device access to the console connection. This is also limiting access to the user mode. What is the command to do that? It is the console password. It is the console password. The next one, this will limit device access over Telnet. By default, the login command is included on any VTY lines to prevent Telnet access to the device without authentication. What would this one be? This is a VTY password, a virtual interface password. Again, we are going to be practicing these all the time, okay? All the time. Let's see. Recap. We're just limiting access to our device configuration. We've already talked about the enable secret and the user. Here's the command to protect this user exec. You go into the line console 0 and you set a password on the line console. The line console is how people console in, so how a user would get into it. To secure remote access, we would use the line VTY015. If this seems a little strange, don't worry about it. We're going to be practicing this a lot, okay? We'll be practicing this a lot in our labs. We'll be doing them in labs and packet tracers, okay? Just like the line con 0 needed the login command, so does the VTY. It needs the login command. Here are actual examples of configuring these. So the privileged exec password. I'm going to set passwords from the global mode. I go into configure terminal and I type enable secret class. The reason we use the word secret is because that encrypts the word class. You could type enable password class. That is not as secure though, and we no longer use that as a best practice. Or as a best practice, we no longer use that. We always use enable secret class. The line console, we do that from global mode. Line con 0, line console 0. Password Cisco, login end. This does not have the ability to use the secret within the line. On line VTY 0 through 15. The reason we use 0 through 15 is your device could have up to 16 different virtual interfaces. Same thing here, password Cisco, login end. Notice here that in these examples, we've only used the word class and Cisco. In the real world, you would not always use the same password, class and Cisco. We do that in class because sometimes people would use wildly difficult passwords and we could never figure it out to clear the devices. And we're in a lab environment where everybody needs to be able to get onto the routers and the switches. So please always just use the password of class and Cisco unless you're explicitly told otherwise, okay? And this is for our labs. When you do packet tracers, go ahead and use whatever the packet tracer password is, because that's not affecting something that other people have to use. The packet tracer is specific to you. So there's no problem using whatever password they're telling you to use through Net Academy. All right, we know how to choose passwords. Make them difficult, use a combination of letters, numbers, don't use the same password over and over, etc. What command prevents passwords from showing up as plain text when viewing the configuration files? Now, this question might seem a little tricky because a slide ago we talked about the word secret. But this is specifically talking about configuration files. This isn't talking about moving from mode to mode. Oh, it's a multiple choice. Okay, is it enable password, login, service password encryption, or line con 0? Don't pick enable password. First of all, we've already learned that enable password is a less secure way to protect your privileged mode. Don't use that. Login isn't a password setting command. Neither is line con 0. So if you chose service password encryption, you would be right. This is a command that will encrypt passwords that would normally show up in your configuration files. This command causes the encryption of passwords to occur when a password is configured. This encryption applies only to passwords in the configuration file, not to passwords as they are sent over the media. Once applied, removing the encryption service does not reverse the encryption. So even if somebody that's not supposed to get in on your network goes in and removes that command, the passwords that got encrypted will stay encrypted. Let me show you an example. Here is our switch floor 1. We're entering the command service password encryption. And then I type exit because I want to look at the configuration files. Here we have it. Enable secret. This is encrypted. Now, the enable secret encrypted that password. However, this is for what we see, okay? It messes it up so that we can't even see it in the configuration files because I don't want somebody looking over my shoulder and being able to see what my passwords are. Line con 0. When I set the password of Cisco or class, again, here it is, it's encrypting it. The line VTYs, it's encrypting it, okay? That's what service password encryption does. Another security mechanism is something called a banner message. It's an important process that we as network administrators do for legal backup. You've probably seen this when you enter the school's computers. You get a message that pops up that says, this is property of Glendale Community College or Maricopa Community College. Access to this is provided to you at the sole discretion of Maricopa Community Colleges. Don't do anything illegal. That is a banner message. And we have control over what we put into the banner message. And we would do the same thing for our networking devices. This router is owned by Intel. Stay out or else we'll come after you. You know, that type of a thing. Now you can also use a banner message to share important information. Something I might do is say, stay out and give that legal clearance, but then also say, Andrea Shower, network administrator, contact information, and then put like an 800 number or some sort of a cell phone number that if I wanted people to be able to contact me, they could. Okay. How do we write a banner message? The command is banner. The keyword is MOTD, and it's a keyword because MOTD is something we always use, and it will be recognized by the device. Then we follow that up with an argument, and the argument is what we actually type as our message. In this case, this is a secure system, authorized access only. Notice how you need to put what's called a delimiting character at the beginning of your message and the end of the message. And it can be the hashtag, it could be an exclamation point. They just have to match. And that's how the iOS knows what you intend the message to be. I want to say something about what we do in our class. Just like on the host names, you use your initials. I also want you to put specific information into the banner message. And this is what you would put. Now, this is as if I were the student. So I'm going to put network administrator Andrea Shower, because I'm administering this network that I'm building. If it's you building a network, you'll put your name. CNT150, or whatever CNT class you're in. If you're in CNT140, CNT150, CNT160, your section number, and then whoever your instructor is. So this example, Pam Kimbrough, that's the instructor. And then I put whatever my banner message is. This is a secure system, stay out. Okay, we'll give you some reminders about how to do this, but you'll do this always and forever when it comes to doing labs. This is another good time to take a little break. We pretty much have finished talking about the basic security commands and the different ways that we would protect our modes. Before we start talking about saving configuration files in the configuration files, let's take a break. We're making all of these changes to our devices. We're configuring the switch. We're configuring the router. Well, this information has to be stored someplace. And that is going to be stored in files called the running configuration or the startup configuration. There's two system files. The startup configuration is NVRAM, non-volatile RAM. So the startup configuration is stored in NVRAM. It contains all of the commands used by the device on the startup or when it gets booted. When you go into a device, there will already be some basic things done and set up. That is the startup configuration. In order to see the startup configuration, from privileged exec mode, you would type show startup configuration. The next type of configuration is the running configuration. The running configuration is in RAM, random access memory. What that means is that it is not permanent. So if you don't save what you're putting into the running configuration, it will be lost. If your device loses electricity, it will be lost. It is just stored in RAM, random access memory. That is not permanent storage or non-volatile. As you set a host name, you would want to type the command copy running configuration or copy running config space startup config, because what that will do is it will take whatever you're typing into the running configuration that's not permanent yet, and it will move it into the startup configuration So it's there the next time you turn on your device or the next time you go into your device. It saves it. What you want to what you want to take away from this is the startup configuration is permanent. It stays in the memory. The running configuration is what you're changing in the moment that you're typing commands. And if you want to keep that information, you need to do a command, copy running config space startup config. That moves it into the non-volatile storage. Save your configurations after the running configuration. We're going to be doing this all the time, okay, in lab. So I'm not going to go into it much deeper. There is something else to know, and that is if you've changed your configurations and you do not have the desired effect, so you're typing into the running configuration, they can be removed individually, or the device can just be rebooted by typing reload. So let's say I enter a host name, I enter some IP addresses, and then I realize, oh man, I'm not even on the right device. I can just type reload and it will take out what I just did and I can start fresh. When you are done with labs, okay, at the end of class, or if you came to open lab and you're all done, after you've done your copy run starts and you've got everything working the way you want, we do want you to get rid of what you did, because I want the devices to be set back to the original startup configuration if another student has to do a lab on the same devices. When you're done with your labs, you're going to type erase startup config from privileged mode. And then you'll do a reload and you'll back out of it. We're going to practice this in class. This module also begins to introduce us to IP addressing. We are going to do a ton of stuff with IP addressing. I am not going to spend a lot of time covering this right now because we're going to be doing it in class together and you're going to practice this all the time. So I'm not going to spend a ton of time talking about it on this video. Just do know that every end device on a network needs to have an IP address, something called a subnet mask, and a default gateway in most cases. We can set IPv4 addresses or IPv6 addresses manually or statically. We will practice this in class. When you set something manually, you've got to go into the control panel. We'll show you an example in class. There's also a way to set your device back to an automatic IP address. This is called DHCP, Dynamic Host Configuration Protocol. Something else that we'll be doing, I think that's module, I don't know, like 10 or 11. We'll be talking about DHCP. More about addressing. This is more about DHCP, ports and addresses. We're coming towards the end. If you think you need a break, take a break, because this is another super important concept and topic that will come up forever in networking. And that's ports and addresses, interfaces. And we're specifically going to talk about something called an SVI, a switch virtual interface. These are virtual interfaces. There's not a physical port on the device. If you've already seen our routers and switches, you'll see all these ports where you could plug a cable in. Well, a virtual interface is just built into the software. There's not a physical port. The virtual interface provides a way for us to remotely manage the switch over the network. And it will always default to something called VLAN 1. Again, VLAN 1 is something you don't need to understand this very second because we'll be talking about it and doing a lot more later. Networks depend on interfaces and the cables that connect them. Different types of networks need different media. Remember, media in networking terms are the cables, the radio frequency, the fiber optic. Ethernet is the most common thing, and we're going to be going over this more in Module 4. I do want to talk about this switch virtual interface. In order for us to remotely get into a device, it has to have an IP address. All networking devices need to have an IP address. Now, when you set up your home computer, it has to have an IP address in order to function. And that gets assigned through the ISP. And then when we set up routers, we'll also be going in and configuring IP addresses. We'll do all of that. A switch, on the other hand, doesn't automatically have an IP address. And the reason is because a switch functions at layer 2 of the OSI model. The OSI model is something we talk about in Module 3. And it uses MAC addresses, not IP addresses. We have to learn how to give the switch an IP address. And we do that using this VLAN 1, okay? VLAN 1 is a virtual interface, an interface VLAN 1. This is just an example. The switch still needs to have physical ports configured and the VTY, which is the virtual one, in order to manage it. So it's going to have both. We're going to do this in the packet tracers, and we're going to do this in lab. I think that will help bring this all together so that it makes more sense. Just make sure you're aware that we've got to learn how to do an SVI. It's not difficult. We just need to do it. A loopback address is another type of virtual or logical address, and we can use that to confirm that the TCP IP is installed and working. This also is something we're going to do in class. We don't have to talk about it a lot right now. It will come up in your packet tracers in your lab. It is a way that I could ping myself and verify that my computer is on the network. Okay, that brings us to the end of Module 2. As you can see, this is a pretty big module, and there is a lot of stuff to know. It is mostly stuff that we're going to be practicing all the time, though. I do recommend that you start a little file with commonly used commands and practice them all the time. Before you know it, probably by the end of the 4th week, you'll be knowing enable, config T, line interface, line con 0, line VTY 015. They'll get easier and easier for you. Until then, if you've got a little file or a Word document with those commands, you'll be able to refer to that. The last thing I want to do is give you a preview for the next module. And again, I recommend that you watch all of the videos inside of the module through Netacad. They're outstanding. Module 3, again, is pretty big, and there's a lot of new concepts and terminology. I want you to really spend a lot of time thinking about Module 3 and getting on board with what's in Module 3. Let's see. So the first video is about the rules, okay? And that is that in networking, you have to have a sender, a receiver, and then the media that the data is going over. You need to have something called timing set, and you want a confirmation on the other end that the data was received. What is a protocol suite? What are the protocol suites? What does the term encoding mean? And along with that, decoding. What are the message delivery options? What are the message delivery options? Network protocols. Why do we have them? What is important about a network protocol? What are the different standards? So everything has a standard. that it has to meet. So an Ethernet port has to have a certain speed. It has to have a certain size, a certain capability. Same goes with a cable. It has to have a certain type of RJ45, the connector, right? There's standards. What are the organizations called that create and manage these standards? What is the TCP IP model and the OSI model? I'll tell you, those are the protocol suites. What are the differences and the similarities? Specify the layers and the functions. I really want you to memorize the 7 layers of the OSI model, the 4 layers of the TCP IP model, and then what are all of the 5 PDUs, protocol data units. What is data encapsulation? Module 3.6, it says watch the animations. There's a great video animation in the module that explains encapsulation. Also in the learning resources, there's an extra, I think, document tutorial to help understand what encapsulation is. What are the terms segmenting and sequencing mean? What are the PDUs? And then what are the different address types and uses? As you can see, there's a lot of stuff. Don't get too nervous. We've got time to learn all this stuff. This is our initial looking at everything, okay? And we do cover a lot of material. It's not that the material is hard, there's just a lot of it. So just keep up your good work, keep going through the learning resources, and remember, we're gonna get to cover a lot of this stuff in class. If you have specific questions, make sure you write them down so that we can help in class. The end. Reminder, read and scan your module for details, and the learning resources has lots of good information. That's all. Have a great one.